Coming to the first problem, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So the first polynomial given to us is x square minus 2x minus 8. So in order to find the zeros of the given quadratic polynomial, we need two integers such that their sum must be equal to minus 2 and product must be equal to minus 8. So by method of splitting, we can write the given quadratic polynomial as x square minus 4x plus 2x minus 8. So that minus 4 plus 2, the sum is minus 2 and the product minus 4 and 2 is minus 8. So minus 4 and 2 satisfy the two conditions of the sum and the product, that is x square minus 4x plus 2x and minus 8. So taking x as common, we get x minus 4 plus 2 times of x minus 4, which is x minus 4 times of x plus 2. So in order to find the zeros of the polynomial, the given polynomial x square minus 2x minus 8 must be equated to 0. X square minus 2x minus 8 can be written as x minus 4 times of x plus 2, which is equal to 0. So we can say that x minus 4 is equal to 0 and x plus 2 is equal to 0. So transposing minus 4 to right hand side, we will be getting x is equal to 4, and transposing plus 2 to right hand side, we will be getting x is equal to minus 2. So the zeros of the given polynomial are 4 and minus 2, and sum of the zeros is equal to 4 plus of minus 2, which is 4 minus 2, which is equal to 2. So this 2 can be written as minus of minus 2 divided by 1. So if we observe, minus 2 is nothing but it is coefficient of x, and in the denominator, in place of 1, we can write the coefficient of x square. We can say that the sum of the zeros is equal to negative of coefficient of x divided by coefficient of x square. So now the product of the zeros is equal to (4) multiplied by minus 2, which is equal to minus 8. So minus 8 can be written as minus 8 by 1. If we observe, minus 8 is a constant term, so we can write constant by 1 is nothing but the coefficient of x square. Therefore, we can say that the product of the zeros is equal to constant term by coefficient of x square. Coming to the second bit, which is 4s square minus 4s plus 1. So let p of s be a polynomial which is equal to 4s square minus 4s plus 1. So in order to find the zeros of the polynomial p of s, we need to factorize the given polynomial. So 4s square minus 4s plus 1 can be written as 4s square minus 2s minus 2s plus 1. This is equal to 2s times of 2s minus 1 minus 1 times of 2s minus 1. So we can take 2s minus 1 as common. We will be getting 2s minus 1 times of 2s minus 1. So in order to find the zeros of the polynomial, we need to equate the polynomial to 0. We will be getting 2s minus 1 times of 2s minus 1 is equal to 0. So we can write 2s minus 1 is equal to 0 and 2s minus 1 is equal to 0. Transposing minus 1 to right hand side, we will be getting 2s is equal to 1, and in the similar manner here also we will be getting 2s is equal to 1. Therefore s is equal to 1 by 2 and s is equal to 1 by 2. The zeros of the polynomial are 1 by 2 comma 1 by 2. So sum of the zeros is equal to 1 by 2 plus 1 by 2, which is equal to 1. So 1 can be written as minus of minus 4 divided by 4. This is equal to minus of minus 4 is nothing but the coefficient of s, and 4 is the coefficient of s square. Therefore we can say that the sum of the zeros is equal to minus of coefficient of s divided by coefficient of s square. So now product of the zeros is equal to one by 2 times of 1 by 2, which is 1 by 4. So 1 is nothing but the constant term and 4 is nothing but the coefficient of s square. So we can say that the product of the zeros is equal to constant term divided by the coefficient of s square. Now coming to the third bit, which is 6x square minus 3 minus 7x. So let p of x be a polynomial which is equal to 6x square minus 7x minus 3. This is by rearranging the given polynomial. So in order to find the zeros of the given quadratic polynomial, we need to factorize the polynomial. So p of x is equal to 6x square minus 9x plus 2x minus 3. So this is by splitting of the given polynomial, which is 6x square minus 9x plus 2x minus 3. So now we can take 3x as a common, 3x times of 2x minus 3, and here we can take 1 as common. This is 1 times of 2x minus 3. This becomes 3x plus 1 times of 2x minus 3. In order to find the zeros of the polynomial, we need to equate p of x to 0. We will be getting 3x plus 1 times of 2x minus 3 is equal to 0. Therefore 3x plus 1 is 0 and 2x minus 3 is also equal to 0. So transposing plus 1 to right hand side, we will be getting 3x is equal to minus 1, and here transposing minus 3 to right hand side, we will be getting 2x is equal to 3. Therefore x is equal to minus 1 by 3 and x is equal to 3 by 2. Therefore the zeros of the given polynomial are minus 1 by 3 and 3 by 2. Now the sum of the zeros is equal to minus 1 by 3 plus 3 by 2. So the LCM can be taken as 6, and this is equal to 2 times of minus 1 plus 3 times of 3. So minus 2 plus 9 divided by 6, which is nothing but 7 by 6. Now sum of the zeros is equal to 7 by 6. So this is written as minus of minus 7 divided by 6. We observe minus 7 is the coefficient of x. So minus of coefficient of x, and 6 is the coefficient of x square. So this is nothing but coefficient of x square. Therefore, the sum of the zeros is nothing but minus of coefficient of x divided by coefficient of x square. Now, the product of zeros is equal to minus 1 by 3 multiplied by 3 by 2. So 3 and 3 can be cancelled and we'll be getting product of the zeros as minus 1 by 2. Now, minus 1 by 2 can be written as minus 3 divided by 6. Here, if we observe, we can say that minus 3 is the constant term divided by 6 is nothing but the coefficient of x square. So the relation is product of the zeros is equal to constant term divided by coefficient of x square. Now coming to the fourth bit, which is 4u square plus 8u. So let us write down the polynomial p of u is equal to 4u square plus 8u. In order to find the zeros of the polynomial, let us equate the given polynomial to 0. That is 4u square plus 8u is equal to 0. So we can take 4u as a common. 4u times of u plus 2 is equal to 0. From this we can say that u is equal to 0 and u plus 2 is equal to 0. So this is equal to u is 0 and u is equal to minus 2. Therefore, the zeros of the given polynomial are 0 and minus 2. Now, the sum of the zeros is equal to 0 plus of minus 2, which is minus 2. This is written as minus of 8 divided by 4, which is nothing but minus of 8 is nothing but the coefficient of u, and 4 is nothing but the coefficient of u square. So we can conclude that the sum of zeros is related to the coefficients as minus of coefficient of u divided by coefficient of u square. Now the product of zeros is equal to 0 multiplied by minus 2, which is nothing but 0. This is equal to 0 divided by 4, which is nothing but, since we don't have the constant term, we can say the constant term is 0. So the 0 is the constant term, nothing but constant term divided by the coefficient of u square. Therefore, the products of zeros is related to the coefficients as constant term divided by coefficient of u square. Now coming to the fifth bit, which is t square minus 15. So the polynomial can be written as p of t is equal to t square minus 15. So in order to find the zeros of the polynomial, let us equate the given polynomial p of t is equal to 0. So this can be written as t square minus 15 is equal to 0. Therefore, we can say that t square minus of root 15 whole square is equal to 0. This is in the form of a square minus b square, which is equal to a plus b times of a minus b. So this can be written as t plus root 15 times of t minus root 15, which is equal to t plus 15 is 0 and t minus root 15 is 0. So we can say that t is equal to minus root 15 and t is equal to plus root 15. Therefore, the zeros of the polynomial are plus or minus root 15. Now, the sum of zeros is equal to plus root 15 minus root 15, which is nothing but 0. So we can say that 0 minus of 0 divided by 1, which is minus of 0 is nothing but the coefficient of t divided by 1 is nothing but coefficient of t square. So we can conclude that the sum of zeros is equal to minus of coefficient of t divided by coefficient of t square. Now the product of the zeros is equal to plus root 15 multiplied by minus root 15, which is equal to minus 15. This can be written as minus 15 divided by 1. If we observe, minus 15 is a constant term and 1 is the coefficient of t square. So we can say that the product of the zeros is equal to constant term divided by coefficient of t square. Now coming to the sixth bit, which is 3x square minus x minus 4. Let us write polynomial p of x is equal to 3x square minus x minus 4. In order to find the zeros of the polynomial, let us equate the given polynomial to 0. That is 3 of x square minus x minus 4 is equal to 0. So let us factorize the given polynomial. By splitting method, we can write 3x square minus x minus 4 as 3x square minus 4x plus 3x minus 4 is equal to 0. Now taking x as common, we will be getting x times of 3x minus 4 and 1 as common, we will be getting 1 times of 3x minus 4 is equal to 0, which is x plus 1 times of 3x minus 4 is equal to 0. This becomes x plus 1 is equal to 0 and 3x minus 4 is equal to 0. This is x is equal to minus 1 and x is equal to 4 by 3. Now the sum of the zeros is equal to minus 1 plus 4 by 3. So this can be written as the LCM is 3 and minus 3 plus 4, which is 1 by 3. So 1 by 3 can be written as minus of minus 1 divided by 3. If we observe, minus 1 is the coefficient of x. So minus of coefficient of x divided by 3 is nothing but the coefficient of x square. So the sum of the zeros is equal to minus of coefficient of x divided by coefficient of x square. Now the product of the zeros is equal to minus 1 multiplied by 4 by 3, which is minus 4 by 3. If we observe, minus 4 is the constant term. So in place of minus 4 we can write constant, and 3 is nothing but the coefficient of x square. So the product of the zeros is equal to constant term divided by coefficient of x square.